Kia ora, year 12 and 13. In this video I'm going to look at how to find the equation of a tangent to a conic. So this uses implicit differentiation, which you hopefully will all remember well from our differentiation topic. So the first question is, what's the equation of the tangent to the curve y squared minus 2y minus 4x plus 4 equals 0? Okay, and we're looking for that at the point 1, 2. I could just do this algebraically, but I want to first of all take a look at what kind of conic section we've got here. So we're going to do our usual thing, which is to complete the square. Now we don't have to do this to answer this question, but it's a good thing to do anyway. So completing the square on that first one, it's in the right order, so I'm going to get y minus 1 squared. I've added in 1, so take out the 1. Right, minus 4x plus 4 equals 0. So I've got y minus 1 squared equals 4x minus 3. In other words, it's a parabola that looks like this: 4 times x minus 3/4. So it's a parabola centered on 3/4 and 1 with an a of 1. So it's going to look something like this. So here's 3/4 here, and here's 1 up about here. Right, so that'll be the vertex, and a is 1, so my focus is 1 back there. The latus rectum is going to be 4a, so plus or minus 2 from this value here. So there. So that'll be at 1, that'll be at 3, and down here this will be at negative 1. Now that's ghastly, that's really rough, but at least it gives us an idea of what we're looking for. So at the point 1, 2, we're going to be finding the equation of the tangent. Alright, so if you have a good feel for what the curve looks like first, you're least likely to make mistakes. On the next slide, I'm going to do the differentiation and the algebra. So we're going to work with this version of the curve in expanded form. Okay, so it's y squared minus 2y minus 4x plus 4 equals 0, and that's at 1, 2. Right, so 2y dy by dx minus 2 dy by dx minus 4 equals 0. Collecting up terms, dy by dx into 2y minus 2 equals 4. So dy by dx is equal to 4 over 2y minus 2, which is the same as 2 over y minus 1. So that's going to be my m in my straight line equation, which is this one here. Okay, so last thing I need to do is I'm going to take my y value and pop it into my equation for the gradient. So m is equal to 2 over 2 minus 1, which is equal to 2. So, putting a new slide in, we're going to end up getting y minus 2 is equal to 2 times x minus 1. Now, I know this is going to be a crowded slide, but I'm going to try and get away with it on here. So, manipulating that, we get y minus 2 equals 2x minus 2. So my equation is simply y equals 2x. Now, if we look back at the badly drawn parabola on the last slide, we can check that that looks right. Right, so if you pause and go back and do that, you'll see that it does look perfectly right. So we've got our answer, y is equal to 2x. Right, one more example coming on the next slide. Okay, so again, what's the equation of the tangent to the curve 2x squared plus 3y squared minus x plus 2y minus 29, and of course it needs to equal something, so that equals 0, and then negative 3, negative 2. So this is actually delta 38.2, question 1G. Delta 38.2 is full of lovely examples on tangents and normals, and I recommend that you chug through a bunch of them. So let's differentiate this. We get 4x plus 6y dy by dx minus 1 plus 2 dy by dx. This goes to 0 and this stays at 0, so that equals 0. So collecting up terms, we get 4x minus 1 plus dy by dx, 6y plus 2 is equal to 0. We need an expression for the gradient. Dy by dx is equal to 1 minus 4x over 6y plus 2. And we want to find that gradient at this point. So we're going to substitute in both the x and the y values, and we'll call it m, shorthand for the gradient. So m equals 1 plus 12 over negative 12 plus 2 over negative 10. Yuck, which is negative 13 over 10. On the next slide, we'll get the equation of the tangent using that gradient. Okay, so we had m equals negative 13 over 10, and the point we're trying to do this at is negative 3, negative 2. So it's y minus y1 is equal to m times x minus x1. So y plus 2 is equal to negative 13 over 10 x plus 3. Right, be careful here, clear out your fractions. We get 10y plus 20 equals negative 13x minus 39. We can write that in two ways. With these, it's usually easiest to use the ax plus by plus c equals 0 form. You'll find that that's what New Lake and Delta both do, and that works well. So here we're going to get 13x plus 10y. So that's adding that to that side, leaving that there, and I'm going to add 39, so I get plus 59 equals 0. Alright, so that's all for now. I'm going to do another equation soon about how to get the equation of the normal, but most of you should be able to do that now. So, as I said, lots of practice in Delta on these, please, and it's exercise 38.2 on page 379. Thanks for watching.